All right, so next up we have the solution to the flashlight problem. This should be about slide 83-ish. Okay, so for this, the question states the EMF of a flashlight is equal to 1.7 volts, and the battery is about 4.5 centimeters long, and the radius of the battery is equal to 1 centimeter. And we want to estimate roughly the charge on the positive plate of the battery, so Q positive for battery. Okay, so what we're going to do is we're going to treat the battery like a capacitor with a separation of 4.5 centimeters. And we're going to use the electric field being approximately equal to Q over A over epsilon naught. Now, since we're treating the battery like a capacitor, then we can say if E is uniform, then delta V is equal to E times L, where L is the distance between the plates. And so delta V, we're going to say is equal to EMF. We're going to assume ideal battery. So then we'd have delta V over L is equal to Q over A divided by epsilon naught. And so then Q is equal to epsilon naught A delta V over L. And if we plug in our values, so 8.85 times 10 to the minus 12 Coulomb squared over let me just use a new piece of paper. Let's not be ridiculous. Okay, so Q is equal to 8.85 times 10 to the minus 12 Coulomb squared over Newton meters squared pi times 0.1 or 0.01 squared, that's the area, times 1.7 volts, that's EMF, divided by 0.045, that is the length. And so we get charge is equal to 1.05 times 10 to the minus 13 coulombs. Now we're asked to compare that to the charge of a tape. So charge on tape, we estimated in chapter 14 to be approximately 10 to the minus 9 coulombs. And we can see that that charge on that positive plate is very, very tiny, even compared to the charge on a tape. So that's about, this is about 10,000 times smaller than the charge on a tape. So it doesn't really make any significant difference.